Welcome to this explainer. Today, we're diving into the fascinating world of elasticity of demand and decoding the hidden forces behind pricing. Have you ever wondered why a tiny discount on one item causes an absolute buying frenzy, while a massive price drop on another barely moves the needle? Well, today, we are unlocking the mathematical secrets that drive consumer behavior and revealing exactly why understanding this concept is absolutely crucial for modern business strategy. Here's our roadmap for today. We're going to cover beyond the law of demand, price elasticity of demand, income and cross-elasticity, measuring price elasticity, the unitary demand curve, and finally, factors determining elasticity. Let's jump right in.
Section 1. Beyond the law of demand. To start, we need to realize that the basic law of demand only tells us the direction of a change, not the actual magnitude. Think about it. We all know the foundational rule of economics, right? If the price of a commodity falls, the quantity demanded increases. But that leaves us with a pretty massive blind spot. This is the ultimate mystery for businesses, and solving it is crucial for anyone trying to maximize profits or predict market shifts. We know lowering prices brings more buyers, but by exactly how much? If we slash prices by 10%, are we going to double our sales or just see a tiny little bump?
The mathematical solution to that mystery is what we call the elasticity of demand. It basically acts as our magnifying glass, quantifying exactly how our dependent variable, which is demand, responds when we mess around with independent variables. Things like the product's price, the buyer's income, or even what a competitor is charging. We aren't just looking at demand in a vacuum, we're measuring exactly how sensitive it is to the real-world forces constantly pushing and pulling on it, usually calculated as a percentage change.
Now, to actually isolate the specific culprit that's changing our demand, we use what's called a partial equilibrium approach. This just means we change one variable at a time, holding everything else totally still. It's like being a scientist in a lab. If you change the price, the customer's income, and the competitor's price all at the exact same time, you're never going to know which factor actually caused the demand to shift. So we freeze everything else. We change only one independent variable to see its pure, unfiltered impact.
Moving on to Section 2, price elasticity of demand. Let's interrogate our very first suspect, the product's own price.
This concept was devised by the legendary economist Alfred Marshall. His formula measures relative responsiveness. Simply put, you take the percentage change in the quantity demanded and divide it by the percentage change in the price. Now, here's a quirk. Because price goes down when demand goes up, and vice versa, the math almost always spits out a negative number. Keep that in mind. But for the sake of easily categorizing how elastic something is, economists often just look at the absolute value.
And when we do that math, we can categorize the results perfectly. On one extreme, we have perfectly inelastic, where the value is 0. That means no matter how high the price goes, people buy the exact same amount. Then there's unitary elastic, which is a perfect 1-to-1 ratio. But where it gets really interesting is relatively elastic. That's a value greater than 1. For instance, dropping the price of gourmet chocolate by just 10% might trigger a massive 30% spike in demand. On the flip side, if demand only goes up 8% after that same 10% price drop, we call that relatively inelastic.
Section 3. Income and cross-elasticity. So what happens when we look past the product's own price and start looking at the buyer's wallet and the rest of the market?
Let's factor in consumer income. If we calculate income elasticity and get a coefficient like positive 2.5, that tells us the item is a normal good. That means a 10% increase in people's income causes a whopping 25% jump in demand. Notice the positive sign here. Unlike price elasticity, income elasticity usually features a direct relationship. As people earn more, they buy more. It is an amazing indicator for predicting how a product will perform when the economy is growing.
Then we have cross-elasticity, which is all about market relationships. It measures how the demand for one commodity reacts when the price of a totally different commodity changes. If Pepsi's price goes up and suddenly everyone buys more Coke, you get a positive coefficient. Those are rivals or substitutes. But if the price of cars skyrockets, the demand for petrol drops. They move in opposite directions, giving us a negative coefficient, meaning they are sidekicks or complementary goods.
So for example, if you calculate a cross-elasticity of negative 1.6, you instantly know you're dealing with an inverse relationship. It proves those items, like cars and petrol, are tightly linked complements. Other classic examples are motorbikes and petrol or smartphones and SIM cards. Their fates in the market are completely tied together.
Section 4. Measuring price elasticity.
We know the suspects, so let's look at the actual tools economists use to measure them. We actually have 3 distinct methods, and you use them depending on the situation. First up is the point method, which is strictly for microscopic, tiny shifts in price and quantity. Second, when the changes are a bit larger, we use the outlay method. This one tracks the total money spent by consumers. And third, if we want to visually measure elasticity along different points of a demand curve, the geometrical method is our go-to tool.
Let's dig into that outlay method for a second, because it's brilliant for visualizing consumer spending. Imagine mapping out total consumer outlay, the total money spent as prices rise. Initially, you might see that as price goes up, the total money spent goes up too. That direct relationship means elasticity is less than unity. But then, you hit a point where the price keeps rising, but the total money spent stays exactly the same. That is unitary elasticity. And finally, if the price keeps climbing and total outlay actually starts falling, that shows an elasticity of more than unity. It's a fantastic way to picture behavior.
Section 5. The Unitary Demand Curve. Let's explore a really unique geometrical scenario that builds right on top of that outlay method.
Imagine a scenario where every single price-quantity combination results in the exact same total outlay. The amount of money consumers spend never, ever changes, regardless of the price point. When you graph that, you get a perfectly balanced curve, known as a rectangular hyperbola. It is this rare, mathematically beautiful situation where the price elasticity of demand is exactly unity, everywhere along the entire curve.
Section 6. Factors determining elasticity. To wrap things up, let's bring all of this academic math back to our everyday reality.
Because ultimately, these mathematical coefficients are driven by real-world factors. Things like the nature of the commodity. Is it a bare necessity, a comfort, or a high-end luxury? Or how many substitute brands are sitting right next to it on the store shelf? Think about it. If you're buying salt or life-saving medicine, demand is highly inelastic. You're going to need it even if the price jumps. But if it's a luxury item, or there are 10 other brands you can easily switch to, demand becomes highly elastic. Even the amount of different uses a product has, or its general price level, can dramatically shift the math.
So the big takeaway here is that pricing isn't just guesswork. It's a measurable science. Understanding price, income, and cross-elasticity and knowing exactly how to measure them is absolutely crucial. It helps businesses maximize profit, and it helps governments predict market reactions and set effective economic policies. Next time you see a massive sale or a sudden price hike, you're going to know exactly what kind of math is happening behind the scenes. So, knowing this hidden math, how would you change the price of your own favorite product? Thanks for joining me on this explainer, and keep questioning the world around you.